I know. I know.
How do you hold the normal camera?
Right now it looks like that.
Yeah, no, it is.
You don't have to hold it like this. I hate this chair.
It's a well-worn chair.
But it doesn't like my leg.
Since yesterday, Pat.
It's well-worn. Those are probably
Much older than I am.
35 years.
Yep.
Every week I put them away, put them out, put them away, put them out. Yeah. Okay, presumably some of you received the email that I sent about how we're going to start today. That's because I was a little long-winded about some of this stuff, the introductory stuff to this particular project. So I didn't finish what I should have. And I'll try to do that today as much as I can, and then we'll take a little break, and then we'll set up for the actual hands-on experiments. Briefly, actually, did describe the projects that we're going to be doing, but in a technical course, it's the fine points that are kind of interesting, that make you think about it a little bit more than superficially, the way that some of we have done so far. But we did talk about distortion of moving images due to interaction with the shutter, which I think is kind of a neat topic to discuss. As which reminds me, I actually could send you another link to. I sent you a link to a page that describes how to use these little flashing lights. I don't know where I had it here just a second ago. I don't know what it was. But that pretty much explains what the flashing light is all about. But there's another aspect to these shutters, and we've talked about it, I mentioned them. It's the difference between a global shutter and what they call a rolling shutter in digital parlance. And I'm not sure if you've experienced it, and if you experienced it, whether you noticed it or not. I must admit I didn't at the beginning. I just assumed that digital cameras operated like any other camera. Well, this rolling shutter bit operates like a focal plane shutter. And so, without going much further, I'd like to just get a show of hands of how many of you noticed this thing called focal rolling shutter distortion in your photograph. 1, 2. You have an iPhone?
I've never photographed it, but I've seen YouTube videos.
Oh, you've seen it. Have you actually seen it in your pictures?
I use my phone for pictures. I have an Android phone, but I've seen that kind of effect.
The way I got acquainted with it is because somebody sent me a photograph of an airplane propeller taken from the cabin, looking at the propeller, and it was weird. There's no way a plane could fly with such a propeller. and the question was, well, what happened here? Well, I didn't know how the shutters operated, but from that photograph you could deduce how the picture must have been made. And then from there on it was a step to actually doing a little bit of additional work to find out, oh yeah, these CMOS sensors operate that way. So you can expect to see, with particularly I think camera phones, but even I think the camera I had here, the 5D, has a scanning type effect sometimes, I think. And it'll be reflected in some kind of distortion in what you photograph. If you take your camera and you photograph, maybe you're driving past some vertical poles, fence or something, and photograph out, you'll notice that the fence may not end up to be vertical. It'll be tilted. That's assuming that you don't pan backwards into things. Racers and so on, bicycle wheels and spokes will tend to get distorted. Propellers, of course. And car wheels also. Not the wheels themselves probably, but the spokes will. So it is an effect that you probably are going to notice, and somebody might say, well, you're an expert, tell me what it is. Well, by now, it's kind of old hat. You know, everybody knows about it. But it just points out the fact that there are some explanations for this, for these effects. And some people know, and some people do not know. Hopefully you all are among the people who do know. You'd like to be in that kind of position. So to extrapolate further to why I thought that we might want to start again, I'm looking for a familiar face. I don't see you. Only because I think he was sitting over there. Only because. Oh no, there you are. What's your name?
David.
David Byron. Did you want your work back from last year?
Yeah, I take it.
Did you write me a note and say,
Yeah.
I like it back?
Oh, actually, I did pick it up.
You did?
Yeah.
From my door?
Mm-hmm.
Oh, great. Okay. In that case, did you pick up yours? Oh, well, it's on my door.
It's like a steel trap. Okay, it's alright.
Okay. No, I think you wrote to me, and so I made an effort to put it on the door. It's not there anymore. But anyway, I digress. I just wanted to make sure that if you wanted your papers back from last, whenever it was, you could get them back. So, what was the part, or what is the part that is missing from this refinement to a very simple experiment? Let's see if I can figure this out. In a different way than I've done before. And you know, in a way it is unfortunate that we have boards like this today, called whiteboards. So what's unfortunate about it? Well, anything I put on it is going to be black. But photography works the other way, isn't it? Sort of in a positive sense. If I were to put a mark on this, I like it to be light, not dark. So I'm going to be drawing black, but in fact, think about it as white, and think about this white as being black. Does that make sense?
Mm-hmm.
Or whatever. So, we'll take a look at pick a subject. All right, nice round subject. What's a subject? Well, it could be this. Okay. Ping pong balls. I have a bunch of them, but none on my hand right now. So, but anyway, round ball. To make this technically maybe more, it doesn't matter. We can start this way. And you know, take a camera, however it is, and it's got a sensor in it, and we put an image over here, and we'll set the camera to some aperture, you know, f8. We'll set the camera to f8 and 1 second. And we make a photograph, and it turns out that this photograph kind of sort of looks like what we photographed. And then we ask some technical questions about this. You know. We could go the analog route, or we could go the digital route. I like the analog one, but it will work either way. And that means we can put a graph down here, okay, of response versus input. So this is going to have in well, if we talk about negatives, okay, it's going to have some high density, and on film we have a characteristic curve like this sort of, and the white should end up over here someplace, right? And the black in the background over here someplace. And over here we have, so many stops difference, maybe in exposure. And that means that this was brighter than that, and it got more density. In the digital realm, it would be pretty similar, except that we do maybe a characteristic curve that looks like this. But you again still would have some high point and some low point and something, all the information in between. It's not like it's neither here nor there. But we understand that. Okay, that's how images are made. Okay. Now, if we choose a different exposure time, half a second, okay, in that case we expect, particularly, the highlights to drop, right? So instead of the highlight of that ball, if we measure it here, being over here, and the digital count being over there, it's now over here. It keeps dropping and dropping. Now, so does the shadow, but it's not so evident eventually, over here as much. It just goes to zero, and over there it goes to like nothing. But we understand that. Yeah, a quarter of a second, and this drops even further. And it drops a little further over here. So eventually we get to the point where this disappears. Right? We don't gather enough information to display it. So you say, well, okay, what does this have to do with anything that we're going to do? Well, we're going to be photographing moving objects, right? On the turntable, we have this arc over here. And we could make a photograph of this turntable just sitting there. And in that case, we could equate maybe the white of the ball with the white of the mark and end up over there, right? And the same in the digital side. So we make a 1 second exposure, and this is just sitting there. And that's what we get. But now, what we're going to do is to imagine that we could put this here for a half a second and put it there for another half a second. So it's here for half a second, it's there for another half a second. The total time, it'll be 1 second, right? But the white mark will have been in any given spot for only half a second. So what do we expect the value of this to be? Well, it would be what this was, right? You haven't done anything. It's just as bright as it was before. It's reflecting just as much as it did before. The thing is, it's not in the same place all the time. We could amplify this and put it in quarters over here. And now, the brightness of this, or the readout of this, is going to be associated with whatever this was. In a way, in sensitometric terms, you could determine the speed at which things are going if you know what the response is for a particular speed. It might be either for a particular speed or for a stationary situation. So what does this mean as far as the turntable is concerned? What is going to happen? Well, if you're, you could proceed kind of blind and make an exposure of this rotating, whirling turntable, rather simple subject. And you look at the picture and it looks okay. And let's say that you start out with the 1 second. You don't have to start there, but let's say you start with that. Then you'd expect this kind of response right here. Highlights high value, shadows low value. And but now you put this turntable in motion, okay, as we're going to, at 33 1/3 RPM. I don't want to use this as an excuse, but I had a broken arm, and it didn't join itself up properly, and I again scribble more than I ever did. No, that's a joke. But I did break my arm. Anyway, so we turn at 33 RPM, that's 200 degrees per second, right? Well, let's assume, just for the sake of argument, that we make this mark here 2 degrees. It's not too small, not too big. 2 degrees. And then we say, well, how long is that mark reflecting light from a particular spot on the turntable? The exposure time is going to be arc size divided by arc velocity, or rate or something. Rate. So this is going to be 2 degrees divided by 200 degrees per second. Yeah, lo and behold, our exposure time is 1/100th of a second, right? But we're measuring with the camera. We say, well, it's a 1 second exposure. That means that we're gathering a lot of information in that 1 second. So we would expect the whites to be up here, but they're not going to be there. They're going to be down here someplace. You say, well, they're going to be underexposed. And you say, well, by how much? Is it significant? Well, you say 1 second, okay, half, a quarter. I can only do this the long way. I could do it for you using logs. Would you like me to do that? Logs are nice. They're good. You're friends. Anyway, either way it works. Do it the gut feeling way. An 8th, 15th, 30th, 60th, and 125th. Let's just go with 125, right? So you say, well, how underexposed is this white object going to be? Well, 1 stop, 2, 3, 4, 5, 6, 7. Wow, it goes from here way down to here. 7 stops under exposure is significant, right? Even for a white object. A white object is supposed to be up there someplace. Drop it 7 stops in the digital world, it'll disappear. That is, if what you do is what photographers tend to do, and that is to say, if I make the exposure time longer, I use a smaller aperture. I think I said that right, but I'm not positive. So, but essentially you say, well, if this is at f8, in that case this is going to have to be at f5.6, right? More aperture, shorter speed. Shorter exposure time, larger aperture. So, but here's this turntable. You've set it up for 1 second, everything is fine, and then you start cutting the exposure time for each. You start cutting the exposure time, but now you say, okay, but I'm going to now, what do? You overexpose, right? Because you go from 1 second, wait a minute, I gotta get the logic right here. You make it for 1 second and everything is fine. You go for half a second, and I think that we're going the opposite way. However, what's going to happen now is that you're going to go in that direction. My gut feeling says that, but correct me if I'm wrong.
If you're decreasing exposure time, you're decreasing the amount of light, therefore if it's underexposed, you compensate by opening that aperture wider.
That would be the natural thing to do, wouldn't it? So, if you started out, at f8 over here, and you shorten the exposure time, and you're going that way, for each drop in exposure time, you open up the aperture, right?
Right.
So you start at f8, 5.6. Let's see if we can do this. 5.6, 4, 2.8, 2, 1.4, 1.7, right? So now you say, oh, okay, well, I'll expose it at 0.7. Okay? And sure enough, you know, what's going to happen is you go in that direction and you way overexpose the highlights. So your signal is getting lost. In one case, it's getting lost in the shadows. In the other case, it's going to get lost in the highlights. However, I have an inkling that I didn't explain this properly. So this is a good chance for you to tell me you didn't get them. What did you actually say? You don't tell me that. I'll assume that I was crystal clear, which I know I wasn't. But this is, to some extent, it is about talking to each other. The ultimate goal of this little discussion is to point out that moving objects become their own shutters, regardless of what, well, I shouldn't say regardless, if they move a distance greater than their own size. Images move greater distance than their own size. If you photograph something that's moving infinitely fast, well, I like to think infinitely fast, but people tell me you can't do that. The likelihood of you catching any trace of an object that is moving very rapidly in front of your camera, and which in fact you happen to see at the time, or happens to pass over the sensor, the signal that you can capture from that gets less and less the faster it moves. Right? So that's sort of the point. And you may experience that. Well, you actually will experience that. How am I going to say that? If you do the photographic thing, which is change the aperture as you change the exposure time. I'm still not convinced that that statement is supported by whatever discussion that I've had here, so I'm a little uneasy about this. So I'm thinking, all right? Let's see what happens if you do the photographic procedure, which is open up the lens at the same time as you decrease the shutter speed. That means that the background images, whatever the object is that's the turntable, for example, is sitting on, will be reproduced at the same signal level throughout your series. So the floor is going to have the same brightness or same density, whichever way you want to go, right? That will be a fact, or as close as photography can get to it, right? But the mark will not.
The mark will be dimmer, won't it? Yeah.
Dimmer, yeah.
No, it'll be harder to see.
It'll be harder to see. It'll be harder and harder to see. Although it depends on where on the scale you start.
Wouldn't it be harder to see with the longer exposure times, but easier to see with the shorter exposure times?
Yes, absolutely.
Yeah.
Because it doesn't move so far.
Right.
So, however, if you start with the shortest exposure times and then you adjust the other way,
you're going to lose it.
Yeah, right. So, again, from the finesse point of view, this is one case where you probably don't want to be changing the aperture, regardless of which exposure time you use.
Doesn't matter what the background looks like.
You don't care about that. You want your signal. You don't care about the background, right? You want that. You want to be able to see the blur. And if the blur disappears either into the highlights or disappears into the shadow, that's no good, because you can't measure it. The thing to do is to start someplace in the middle. And then hope you have enough latitude, so to speak, so that the mark doesn't disappear into the highlights or disappear into the shadows. But when you do that, all of a sudden your background is going to shift in brightness. I think in the digital realm, you might experience that more than in the filmer. I'm not positive about that, but it all depends on how much, brightness range you have, what your sensor can accept. The 7 stops is probably okay. But I'd say, start with an exposure time of maybe, set the aperture for an exposure time of maybe 1/15 of a second. That would be kind of in between, right? And then just keep it there. Whether you shoot at 125th or 1 second. And if you're real interested, you might, since if it is digital, it doesn't cost you anything. Just do 2 sets. One where you keep adjusting the aperture, and one where you don't. And see what you learn from that. Well, whether you learn or not, it's an interesting effect, because you're going contrary to photographic practice, which says change the aperture and change your shutter speed. In this case, well, I'm not going to do that. Okay. This was essentially the major point that I wanted to raise, but at the same time, maybe, we can extrapolate this to the television set also. Because there, too, you have this dot that moves across the CRT screen. And its brightness is constant, but it's in different places all the time. So in that particular case, here you have the cathode ray tube, and you have these lines coming out. Once the screen brightness itself reaches a particular level, in a 1/60th of a second, it scans 262.5 lines, right? But then it scans another 262.5, and it puts them in between or on top of something. So another 1/60th of a second, another 262.5, and for 525. That's as bright as the screen is ever going to get. You filled it with CRT lines. Because after that, it wipes itself clean, starts with another 262. So the brightest this is ever going to get is when you read it at a 30th of a second. So what is it at a, if you expose this at a 30th, this will come out in photographic terms, zone 5 or something, a mid-gray. But it's possible that you underexpose this a little bit. And the reason that you might want to underexpose it is because you don't need it to have such a high value. It could be a little bit lower, and it would tend to maybe make the lines sharper because they wouldn't bleed into each other much. So if you photograph at a 1,000th of a second, in that case you see still the same lines, but they're shorter. That means the slit was smaller. Because that moving line puts the same amount of information in that slot as if it were wide. So this is another case where you set the aperture based on a 30th, maybe a 15th. If you want it to be darker, go to a 60th, and then just leave it there. No need to change. In fact, if you keep increasing the aperture as you decrease the exposure time, that line, or the lines are gonna probably melt into each other because they're gonna be way overexposed. I haven't done this in a while, but I'm pretty sure that that's the case. And with the digital, in the digital realm, it probably worked even more effectively than it did with film. So as far as the experiments that we're going to be conducting, we have the turntable. Which I would suggest you go from 1 to 1,000th of a second. And if you want to go higher, that's okay. Oh, the turntable, 125th maybe. The expectation is that it's going to be harder and harder to determine what the exposure time is as the exposure times get shorter. In this case, with a 2-degree mark, this is only going to move a couple of degrees, and that's going to be hard to measure. Well, it'll move 2 degrees, and if the mark is 2 degrees itself, in that case, the total arc is going to be 4, but from that you subtract 2, right? Because you take the arc out, so you're going from front to front, tail to tail. For the TV, the suggestion is to go from, I'll tell you what, a 30th to 1,000th, okay? Or something like it. And I just want to review this part of it in a second. And with the flashing light, 1 to 125th or something like that. And then determine what the exposure time is for each one of these. And you could probably, I think it would be okay to just display this as a table. Okay? This is what it should have been, and this is what I calculated it to be without figuring out percent errors. Percent errors can be confusing, but that's it. Yeah.
How do you do 1/125th of a second with the light if it's at 100 hertz?
Anybody else want to answer that? It's a good question. It's never been asked. But you get these spikes, right? The LED. The time between here and here is 100th of a second. And what you're saying is, my exposure time is going to be 125th. Yeah, but the shutter could open here, and it could close there. And you get it, don't you? You get one flash. Yeah, you can't really determine what it is, except within some variability. Not on the short side, but on the long side. It's obviously going to be, shorter than 125th. Because or longer. The 125th would be over here, so it's less than this distance. Well, you could make the exposure time that short. You could, in fact, make the exposure time, if this lasts a microsecond, you could make the exposure time a microsecond. And if you're lucky, the two will sync, right? And you'll still get a flash of light, but you won't be able to make any deduction.
Because you need at least 2 flashes.
You need at least 2, and even then,
there's
you're
considerable
prone to
variance
error,
that
yeah,
could have
because
fallen
the
anyway.
shutter could start here,
Yeah.
and it could end there.
Or you could be on both sides or so.
Exactly, right. So you got to be careful with these, okay? But as the time becomes longer and longer, I'm making an error of 1 out of 100. You're talking about 1%. That's not bad. So then you say, well, how can I resolve the problem? Well, make yourself a light that flashes 1,000 times a second. And if that's not fast enough for you, make it something. But now you're solving the problem. Saying this light is not fast enough for my purpose. 100 flashes per second is actually, pretty cool. But it's fairly easy to make these circuits to go to 1,000, 10,000 flashes a second if you want. But then for the long time, it's overkill. 100 is kind of okay for human consumption, so to speak. and maybe a true technical type thing, you might want to work the table comparisons out to percent errors. I'm not going to ask you to do that. Well, in fact, I ask you to ask yourself what you want to do, and if you want to do that on your own, that's fine. But I think it's kind of interesting to take these three methods and then just compare them to each other. Follow the table and say, oh, this is what the TV does, and this is the problems that one runs into with the TV, with the turntable, and with the light. And how do they all compare? Basically, we do want to keep in mind that we're measuring with a standard. A standard is something that is not questioned. So I mentioned this light deal. I have a green one and a white one. I want to use the white one a little bit. Let's use the green one. I think it's on. So there's my 100 cycle per second green light. Can you see it?
Mm-hmm.
Pretty neat. Yeah. 75 cents. Well, not including the battery. I forgot what the reason for this was. Just mentioning this. I forgot. Oh, going back to the standard. I'm telling you, this is 100 cycle per second light. How do you know that? You have to take my word for it. Right? It's like Laura was saying. Somebody decided that this is it. And then you don't question it. Because if you start questioning your standards, forget it. Everything falls to pieces. So you have, at some point you have to stop and you say, that's it. At one point the meter was being designed. Astronomers and people in the Middle Ages or something. And what did they do? They took I'm not even sure, they say it's a platinum bar. You might look up, what's the origin of the meter.
Well, nowadays it's a platinum bar.
Yeah, now it's no longer a platinum bar.
No.
No, it's so many vibrations of something or other. But they took a metal bar like this. Now, they didn't do it totally out of the blue. Somebody put a scratch mark here, put a scratch mark there, and they said, that's a meter. World, that's a meter. That's just, and if you want to know how long a meter is, you're going to come to France, and you can put your measuring stick over there. And that was it. It could have been a little longer, it could have been less. Now, it was refined over time, saying, I'm sure that there was a whole field, obviously, of people who worked with nothing but standards. And at one point they said, well, we want to define it maybe in other terms, in astronomical terms that kind of make more sense. So they did that, and the meter changed a little bit. Well, in the English system, or whatever it's called, the King's system, an inch was, that. Laura said it well. They said, yeah, the King said that's an inch. Okay, fine, we'll go with it. So we're not going to question the standards. The standards, however, may not be compared to the National Bureau of Standards standards. But it doesn't matter, because we're not here, I think the objective is not to be precise on this, as you would want to be, but to understand how it all works. So standards we don't question. You'll be given turntables that are turning at 33 1/3 RPM, more or less. You'll be given a television set that is running at 525 lines every 30th of a second, and I think that's pretty close. But I only think that. And this light, you're going to have to take my word for it. So I think with the covering this material. But I do have, I think in the email I promised you that I would have some printed material related to the turntable and television set test. And I think just about everything that I've covered is covered in this material. If you want to see the original, there is a URL at the top of it, so you could actually see this stuff online if you wanted to. And the one having to do with the lights, I sent you the URL to that. And I think the article has more to do with how to build one of these and what it might do, but the thinking process behind how you would use them is explained. Maybe I can just say one point about that. You know, you make this thing. You say, well, how am I going to find out how fast this flashes? Well, there are sophisticated ways of doing it with oscilloscopes and measuring instruments. Way too expensive. The other thing to remember is that the cameras that you have, people go to great lengths to make sure that the shutter speeds are accurate. Right? Accurate as it can be. So you set your camera to, let's say, 1 second, and you move this around, and you count the number of lights that you see. If you see 100 of them, then this is running 100 flashes a second. So use your camera as your standard. And we're going to do it the other way around. We can use this as a standard to time the camera, but you could go the other way too, right? So, I'm not sure if I did it that way, but that worked. We tend to forget cameras are precision timing instruments. Exploit them. Exploit them. In a technical sense, in any sense. So the plan right now is we're going to get rid of the chairs and open up some space, and I'll set up a couple of work areas for the TV and the turntables. If you give me about 10-15 minutes, we'll do that, and then we'll start to do the work. And I wonder how many of you are missed dinner. How would you like some pizza? All right, well, a little after 7, I think. You can look forward to cheap pizza, but pizza nevertheless. So, give me I need to get rid of the chairs, so you either have to, maybe you can move out in the lounge somewhere, or... And by the way, if anybody wants to make pictures, videos, tapes, you're more than welcome to do that. Of anything, at any time.
You have a question?
Oh, by the way, last week's, or yesterday's, second part of our discussion was, that's on YouTube now. The audio is kind of weak, but jack it up. Yeah.
When we're doing the LED and you sweep the